Hello, everybody, and welcome to Dot to Dot. Well, boy, it's been an interesting summer. We've had a couple of new discoveries with the Rochefoucauld Grail and the Poussin, the Shepherds of Arcadia. And in my last couple of videos, I showed the Shepherds of Arcadia, and I say probably back in July, I was talking about the Rochefoucauld Grail. But what are the odds? What are the chances that these two, actually three, if you add Zena Halpern's map, all coincide together, showing the same geometry, which could be the solution to the Oak Island mystery? Well, I'm going to start off and show you the what we're talking about. And here's the Rochefoucauld Grail. And, it's very small. It was basically created in the 1300s, early 1300s, but it's only 3 inches by 3 inches approximately. I think it's a little bit bigger than that. And this geometry was discovered, the encryption of this geometry was discovered by a subscriber to Olivier and I's channel called Gary. His AKA, his YouTube name is Gazbo. And the Shepherds of Arcadia was created in the mid 1600s by, of course, Poussin. And this dimension of this piece of artwork is approximately 34 by 44 inches. Now, the encryption of this was discovered by a person who has a YouTube channel named My Crypt, Cryptographic Solutions, and his name is Daniel Rodstam. And this over here, of course, is the Zena Halpern map. And it's pretty much, it was discovered by Zena Halpern and Don Rue and Harry Weimer in 2011. But we say that it's probably from the 1900s. So this is most likely created in and around the 1900s. It's it's approximately it's no larger than 6 by 9 inches, so it's actually pretty small. And the encryption of this document was basically discovered by Olivier Schmidt. Now, we've all worked on all these, and we've discovered, the geometry within this. But it's interesting. There's certain things that you need to take in consideration with this geometry. And it's basically uh, three topics. One of them is scale, the other is proportion, and the other is orientation. All the geometry that emanates from these encryptions must have a scale, which means that the not just the picture size is different in each one, but the the geometry that it has a distance associated with it. So this is the scale. And we're going to find that the scale for all this geometry on all three pictures is the scale denoted by Zena Halpern's map, which is the 1347 pede. And that is the initial scale that is represented. And you'll see it's represented in each of the pictures. The other is proportion, and that has to do with the angles and the dimensions of each sides of what is being the geometry being looked at. But most importantly, it's the angles and their position relative to one another, the points that are relative to each other. So this is a very important thing, proportion. The other thing is orientation and how this geometry is oriented to each other, how their points are oriented to one another. And also in the orientation, the practical orientation would be its orientation to Oak Island or to its orientation to north, true north, and south, and true east-west. In order to get a complete picture, in order to get uh, an agreement of those three pictures, you have to have an agreement of all three of these events: scale, proportion, and orientation. And the odds of all these coming together are astronomical. I don't really even know how to calculate it. I did a little bit on a probability calculator just for two events that would satisfy all these criteria: scale, proportion, and orientation. And it comes out to like 1 in 9 million. So that's just two events. And we have more than two events that are happening here. So here we're going to look at these, each one of these today. And I'm going to go to Google Earth and I'm going to show you what is common between all three of these and why it's so important to understand the odds of this. I just gave you 1 in 9 million just for two events to satisfy those three criteria. So let's go to Google Earth. Now, what happens in these? These are the locations and the locations and Nolan's Cross, which, by the way, all the points on Nolan's Cross is represented at least in one of the pictures or one of the encryptions, if not two. For instance, cone A is shown in both the Rochefoucauld Grail and the Zena Halpern map. It's called out. And cone D is in the Poussin and the Zena Halpern map. It's called out there. The red ones are hidden. These are hidden points that are not on Zena Halpern's map. They come out of Zena Halpern's map, but they are also shown in the Rochefoucauld Grail and also in the Poussin. So let's put up, first of all, Zena Halpern's map, since it is the first one that we started with. And just to show you, this is the geometry that comes out of Zena Halpern's map. This is the position where we have the east-west line from the V. And we also, their start point of Zena Halpern's map is cone D. And when we do solve the encryption of the Rochefoucauld note up here in the corner, we get the set point, and we get the 45-degree angle, which is in all of them. And we also get the distance here, which is called out at the Zena Halpern map, which is the 1347 distance, which is from the set point to the 429 extension right here, and also to La Hampe. And both of these are represented in a picture, each one of the pictures. So this is the Zena Halpern's map, and this is the geometry that comes out of that. Now, this is my chalkboard. I'll be using this to show you. So let's go to the next one, which is the last one that I did, the Poussin. Now, this one has a little less than all three of the other two, but it does, this geometry does give us at least this sight line, which is the 45-degree angle, which is common in all of them. It also gives us the location of cone D. And the secret location here is the set point, where these two lines were the intersection of La Hampe. It also gives us La Hampe in this intersection. And this intersection, which is a intersection of this crack mark coming down from here. It was in my last video. So this is the geometry of the Poussin, and the result of the Poussin is basically just these two lines. There may be a geometry connected with the axis of Nolan's cross, but it's not quite as clear as the other two pictures. So this is the geometry that comes out of Poussin, mostly the location of cone D and the La Hampe and the set point. These 3 points are pretty much coming out of that. So let me go to the Grail. And the Grail is very interesting. It's got a lot of stuff. And one of the things I like about the Grail is that there's two angles, or actually two angles and one heading that are called out. Not only is it's called out numerically by counting these squares, and it's marked by the shoes of where to count from, but it's also, the angles are also shown pictorially by the angles of the shoes. So this is uh, the Rochefoucauld Grail, and you notice that in this geometry, the Rochefoucauld Grail gives us the location of cone E right here, and that is a 40-degree angle to what is on the Zena map called the Oak. And this is where you enter, or at least nearby where you enter the underground tunnel. And we also get the set point, and the 20-degree angle is called out here. So it's very specific. And we'll see later that this 40-degree angle and this 20-degree angle, the distance between the 2 points, is the 1347. Another thing to note on this also is that the degrees, the center here, you got 20 degrees on this side and 40 degrees on this side, and the 60 degrees refers to the heading of Nolan's, of this geometry of the axis of Nolan's cross, which is right here. And if we put this on here, you can see it's 60 degrees. So this is a 60-degree heading of true north. And that's what the 60 degrees is referring to, is the heading of the Nolan's cross axis. So let's go back, take this off. So we got the Grail results here. So if you add all these together, okay, and you take the common lines that come out of all those pictures, here they are. What we call the set line, and the line to La Hampe, and to the Oak. All three of these lines are a distance. So the scale is 1347 peed, or or it's 1440 to 1445 feet, depending upon the conversion factors that you use. The other thing is all three of these pictures give this 45-degree angle line, which starts from cone A. This is referenced in La Formula. And La Hampe, being the center of the quadrant of Zena Halpern's map, is shown in the Rochefoucauld Grail and the Poussin. So this is another point that all three of these pictures refer to. This line right here from cone B to La Hampe is just in the Rochefoucauld Grail. But the axis of Nolan's cross is shown in both the Rochefoucauld Grail and in Zena Halpern's map. In Zena Halpern's map, it's done by an inferred Euclidean geometry that when you locate cone D, then you create a bisection of an angle I can put that up real quick. It's the position right here, where on Zena Halpern's map, you locate this, you do a bisection of this angle and create a line perpendicular to this line. So that's how it comes out of Zena Halpern's map. So all these, there's 5 different lines that all are common within these 3 encrypted pictures. They span a timeline of 600 years, from 1300 to 1600s to 1900s. And this geometry is giving us a clue that is only realized when you know the basically la formula, where it tells us to dig 40 feet at the oak, and at 40 feet you dig at a 45-degree angle, and you'll come to the tunnel that will take you to the la hump, which is a valve, and then it will take you to a valve, or to the vault, which is under the earth, the vault under the earth. So here's the common geometry of all 3. I don't know what the probability would be for all these to happen in the same scale, the same proportions, which is the angles, and the same orientation to north-south. It's got to be beyond, it's impossible. It's impossible for it to happen without somebody designing it. And it's certainly something that I cannot do, make fit. In other words, I can't make this fit together. Uh, this has to fit on its own. So this is what the outcome is of the Rochefoucauld Grail, the Shepards of Arcadia, and the Zena Halpern map. Thanks for watching. Like and subscribe, and I'll talk to you later.